In this video, I want to start introducing causal models. We'll then talk about generating data from causal models. So what we're going to try to model is the number of accidents that a person would be involved in car accidents, right? So we'll start by defining this variable, accidents. Define it over here. And that would be, let's say, the number of car accidents that the person is involved in over the course of 2 years. And we'll say, well, what causes accidents? Well, maybe the only thing in our model that causes accidents is dangerous driving. So we'll call this variable danger. So how do we model the relationship between this variable danger and the number of accidents that the person was involved in? Well, so here's one approach. We can say accidents is Poisson distributed. So Poisson distribution, the Poisson distribution, has integer values. So that makes sense. So we'll say accidents is Poisson distributed. And then we want the parameter of the Poisson distribution to be somehow related to this danger variable. So the parameter of the Poisson is also just the mean of the Poisson distribution. So we want to do something that makes sense. We also don't really know how to measure dangerousness, like there's no natural scale for that. So we'll just say it's going to be just a number between minus infinity and infinity, could be any real number. So here's what we'll do. We'll first say it's going to be sigma of danger. And so the sigmoid function you saw a couple times. So the sigmoid function takes a real number, and the value here is always going to be between 0 and 1. So if danger is really small and negative, then sigma of danger is going to be close to 0. If danger is very positive, then sigma of danger is going to be close to 1. Now, we'll say, well, probably the most accidents on average that the person is going to be involved in over the course of 2 years is like maybe 5 or something like that. So we'll multiply this by 5 so that the highest that this could possibly be is going to be 5. The lowest that this could possibly be is 0, which kind of makes sense. So that's what we'll go with. All right, and that exactly defines the relationship between our measure of how dangerous the driving is of the person and the number of accidents that they're involved with. And so let's say now that we want to say, okay, so what causes dangerous driving? And well, maybe one thing that causes dangerous driving is experience. And we're not going to say it's like, years of experience or anything like that. It's again going to be just a number between minus infinity and plus infinity potentially, right? So it's just like a measure of how experienced you are on some kind of scale. So in our model, another thing that causes dangerous driving is aggressiveness. So now again, we need to make a modeling choice as far as how exactly do aggressiveness and experience influence dangerous driving. So here's one possibility. We'll say, okay, so danger, so there's kind of some unknown factors here, but it's going to be a normal distribution, and the mean is going to be, well, something to do with aggressiveness, something to do with experience, and then we'll also have just a constant factor. So we'll say beta naught plus beta 1 aggressiveness plus beta 2 times experience. And the variance we'll just set to 1 just to keep things simple. Okay, so if the larger this variable is, the more aggressive the person is, and the larger this variable is, then the more experienced the person is, then we'll expect kind of just intuitively that beta 1 here is going to be positive because the more aggressive the person is, the more danger, and beta 2 is going to be negative because the more experience, the less danger. Okay, so that is how we're going to do it. Now we get into what we saw in class, the red car thing, right? So we posited that aggressiveness causes both dangerous driving, but it also causes the person to be more likely to drive a red car. That is probably not true, but let's see. Another thing that we posited might cause a person to want to ride a red car is being male. So we'll have another variable, we'll call it male. And we'll say, well, if the person is male, then they're more likely to drive a red car. And in our model at least, we'll assume that those are the only two things that cause the person to drive a red car. So how are we going to do it? So this is either 0 or 1, right? So you either drive a red car or you don't. And we'll do the same kind of thing, except now it's not going to be a normal distribution because we want a distribution that just gives us 0 and 1s, right? Zeros and 1s. So how to do it? So we'll just make it a Bernoulli distribution. So we'll say it's going to be Bernoulli distributed. And now this has got to be a number between 0 and 1, right? Because this is going to be the probability that the output is 1. So we already have a trick for doing that. So it has to be a sigma of something. So we say that driving a red car is caused by being male and caused by aggressiveness. So we'll say this is alpha naught, just because the beta is already taken, plus alpha 1 male plus alpha 2 aggressiveness. Okay? And here we have defined what causes the person to drive a red car. Okay? So that is our causal model.